All right, great. I want to talk about how we can make Ethereum better by making rollups better. But first, let me talk about why Ethereum uses the multi-layer approach and why it's been as successful as it has been. There's been some critique, but I think if you look at it carefully, this has been an incredibly successful approach that Ethereum has taken. The story of layer 2s on Ethereum really goes back to 2014, but it grew to prominence with Vitalik's now famous post on a rollup-centric Ethereum roadmap. And this is where Vitalik sort of explained why it made sense for Ethereum to rely on a multi-layer approach to scale. And I think this, at least for me, it's really inspired by the internet. The internet, which is essentially by far the most successful, open, credibly neutral network that has ever been built by humanity. And one of the reasons the internet and the TCP/IP-based stack was the winner in that space is because of the way that it did layering as opposed to building a monolithic protocol. Because it was layered, it wasn't the fastest at artificial benchmarks, but what it was adaptable, flexible, and reliable in a way that monolithic layers were not. And it succeeded because it became a vehicle for innovation at the higher levels of the stack. And so I think it makes a lot of sense if you're trying to build an open, credibly neutral network to do it in layers. And that's what Vitalik saw, and I think it was actually a very smart thing to do. Now, if you look at the success of this, what you can see is that the growth of layer 2s and layer 3s has grown the capacity of Ethereum by a huge factor. Layer 2 and layer 3, if you look at together how much throughput they have measured as a multiple of Ethereum, you see 30x, 80x, 40x, depending on which measure you use, the speed of Ethereum. Could you make Ethereum L1 faster? Yes, but those same methods would also make the L2s and L3s faster, maintaining these ratios. There's now probably a couple hundred L2 and L3 chains on Ethereum. So this has been a huge growth factor for Ethereum. And just to emphasize this, here's a bar graph that shows the amount of activity at each layer in the Ethereum stack. What you see is that L1 accounts for maybe a couple % of the total activity measured by almost any of the relevant metrics. That's not to say that L1 is not important. It's the foundation on which everything is built. But scaling comes and innovation happens at the higher layers increasingly. And that's why the higher layer approach has been successful. Now, how do we grow Ethereum? Well, there's been a lot of talk about what's Ethereum aligned, what's not Ethereum aligned. There's a bunch of things we don't need. We don't need to build separate silos. We don't need exclusive clubs that only some people can belong to. We don't need rigged games where only some, say, issuer actually stands to profit. What we need is organic activity that is win-win for everyone who's participating. We do also need Ethereum alignment. Now, there's a lot of name calling about alignment, but to me, what alignment means is just this. It means making the Ethereum stack faster, cheaper, more reliable, and easier to use for users and developers. That's alignment, making Ethereum better by making the L2s and L3s better. Everything else is just talk. All right, so how can we do those things? Faster, cheaper, more reliable, easier to use. Let me start with faster. There's a whole bunch of steps we can do to make Ethereum faster, and there's probably no surprise for most people on this chart. Benchmarks, so we have standardized ways of measuring actual realistic performance. Faster VMs, faster database, et cetera, so we can execute faster in a single virtual machine. Parallelism, so we can discover and exploit parallelism in the workload. Now, there are studies showing there's not a ton of parallelism available in realistic workloads, but nonetheless, we should exploit what's there. Better resource pricing, so we can align incentives better so that we can get more user activity done on the same node by causing developers and users to economize on the resources that are truly rare on the node. There's a lot of space for improvement there. And then finally, sharding by horizontal scaling, and by creating horizontal scaling that has less friction than most of what exists today. All right, what do developers need? Well, developers need a bunch of things in order to go faster. They want familiar tools and languages. They want fast execution and full composability. Our answer to that on Arbitrum is Stylus, which lets you write smart contracts in Rust, C, C++, compile them, deploy them directly onto an EVM-compatible chain in a fully composable way. So users and developers don't even have to know whether the contract that they're interacting with was written in Solidity or Rust. Here's a partial list of teams that are already using Stylus. Okay, let me talk about, so horizontal scaling obviously is another example. And again, a huge success in that there are, in Arbitrum alone, about 130 chains. Here's a partial list. But when you take other stacks into account, I think we're well over 200 chains in the L2, L3 space on the Ethereum stack. And that not only gives you a growth in capacity because it's a form of sharding, but also it provides customizability, that individual chains can be designed, governed, configured for the needs of a particular use case. A gaming chain can be configured with very short block times. A TradFi chain might be configured to build in some kind of KYC. Or some other kind of chain might want to sponsor the user's gas fees, or make gas entirely free and have a monthly subscription model. Whatever it is you want to do, different gas token, different economics, you can do that on your own chain. Everyone can't have their own way on a single shared chain, but if you have special needs, you can have your own chain and do it. All right, how do we make things cheaper? Really, the key to making things cheaper is to reduce the cost of operating the chain. At the end of the day, the fees that users pay are going to have to match up. They're going to have to be at least the cost of operating the chain, because VC subsidies don't last forever. And so the core problem here in thinking about design and improvement is how can we reduce the cost of operating these chains without reducing functionality or throughput? And there's a lot of opportunities to do that. A great example here is the adoption of data blobs in Ethereum. Here is a completely unreadable Etherscan page, which shows one of the transactions in which Arbitrum was posting data onto Ethereum. But here's the part you really need to see, that the adoption of data blobs for this typical example reduced the cost of posting by about 40x. How did it do that? Well, it did it by realizing that the way that Ethereum provided data availability provided more functionality than Rollups really needed. And by providing reduced functionality, functionality that was still enough for the Rollups, but was much cheaper to provide for the Ethereum infrastructure, you could reduce the cost of operating Ethereum, and that passes through. It passes through to lower data fees on Ethereum, therefore lower cost for L2s posting data, therefore lower fees for L2 users. This is a great example of clever thinking and the advantage of layering. Okay, better pricing is quite important. Ethereum uses prices to slow down the chain so that everything can get included when there's more incoming traffic than there is capacity. But if we're smarter about when we hit the brakes, so we don't hit those pricing breaks when we don't need to, then we can get more throughput out of the same nodes. And there's a surprising amount of improvement available there. All right, let me talk about how to make it more reliable. And here, here really there is just a lot of hard work. Reliability typically doesn't have a magic bullet. It's just a lot of people fussing over a lot of engineering. But I do want to point to one, and that's not to deprecate that, of course. That's an important factor. But I want to point to one aspect of reliability that I think is often overlooked, and that has to do with reorgs. Right? A reorg is basically creates a dilemma. The possibility of a reorg creates a dilemma for user experience. Either you make the user wait longer until you're pretty confident there's not going to be a reorg, or you tell them that a thing happened and then later have to correct yourself. One of the things you can do in an L2 or L3 is you can make reorgs almost non-existent. So to give you an example, the Arbitrum 1 chain has processed now something like 1.5 billion transactions, and exactly 3 transactions have been affected by reorgs. So your odds of being affected by a reorg are about 1 in 500 million. And that's amazing for user experience because, and really makes the chain in practice seem to be more reliable for users. Okay, easier to use, what are we gonna do there? Here it's really, given that we've gone to sharding, we have hundreds of chains, the key here is interoperability, to connect everything. How can we make an open and performant interoperation standard? And here I think, again, we can take lessons from the internet. There's a lot we can learn here. Internet-style interop has worked out incredibly well. It's been fast, standards-based, asynchronous. You don't stop and wait for the other entity because you don't know how long it will take to get back to you or even if it will at all. It's fault tolerant. You don't assume that whoever's at the other end will necessarily be available. And it's also security conscious. You don't assume that whoever's at the other end is going to be secure. Users can make their own decisions about what to trust and not trust, but you don't build deep layers of mutual trust into the system at the protocol level. So this is the spirit of what we want to do, but I want to talk in particular about something we're doing in the Arbitrum team and Offchain Labs, is the Universal Intent Engine. This is a way this is an open standard for tying together different chains to allow fast interoperation. And I want to talk just briefly about what is the user journey in using this system, and then talk about the solver journey. Now, one thing to note is that there are multiple steps and boxes on here, but that doesn't mean that the user needs to do more than one click. It doesn't mean that the UX has to be complicated, because wallets can provide support for walking the user through this journey with a single click. Okay, so user on the left, they have an intent. The user, let's say, has some funds over on chain A. They'd like those funds over on chain B. They're willing to pay a small fee for that. So the intent says what it is that the user wants. I got 10 ETH here, I want 10 ETH there, I'm willing to pay up to whatever fraction of a % fee for that, and I'd like that done within a certain time frame, within, say, 2 seconds from now. The app or the wallet formats that for the intent feed, and that gets published in the intent feed, which is blasted out to all of the solvers in the world who might be willing to take the other side of that, who might be willing to provide those funds on the destination chain in exchange for getting the user's funds on the source chain. So that goes out into the intent feed. Meanwhile, the user's funds go into an escrow contract. The cross-chain settlement mechanism, which is a black box for purposes of this limited time talk, is able to match up this user intent with the solver. The user then receives their funds on the destination chain, and the cross-chain settlement simultaneously causes these escrowed funds to go to the solver. Now, on the solver side, it works like this. The solver is going to subscribe to the intent feed. It's going to see a bunch of intents. It may decide to bid or quote on some intent. And if this solver is chosen to satisfy this intent, then it will provide funds that will go into escrow, typically very briefly, only maybe even into escrow and then out of escrow to the user within the same transaction in some cases. But the cross-chain settlement mechanism will ensure that the solver receives their funds if and only if the escrowed funds go to the user. This is sort of the happy case path through this. To give you an idea of what's going on, we believe we can do this in across the whole spectrum of EVM chains via open source contracts and an open protocol. And we believe we can do it with very low latency and fully trustlessly. Okay, so alignment, again, means making the Ethereum stack faster, cheaper, more reliable, and easier to use, and providing that for users and developers. That's the key to success. I think Ethereum has done well at those things, especially at balancing all of these goals and being realistic in terms of things like reliability and ease of use. We're going to continue to push on these things, and I'm happy to talk more about these later. The future of L2s, I think, is the future of Ethereum, or I should really say future of L2 and L3 is the future of Ethereum. The Rollup-centric roadmap has been successful so far, and I think it's going to be the key to continued success. And I need to close every talk with the Arbitrum mantra, which is your chain, your rules. Thanks.
Yeah, and with